Good afternoon, all. Am I audible? Hello. Hello. Am I audible?
Yes, ma'am, audible.
Okay, okay. So today we are going to start the
Yes,
week.
audible, audible.
Okay. Today we are going to start the week 8 session, microelectronics device and device to circuit problem solving session. Good afternoon, all. I'm Arpita Biswas, a PhD scholar in electrical engineering department from IIT Jodhpur. This is more details about me, and this class session is every Tuesday 7 to 9 p.m. So let's start the session. So this is the question one. Identify the current source load transistor from the given topology. So carefully see the circuit and find out the right answer. The first option is M3 and M4. The second option is M1 and M2. The third option is M5 and M6. And the fourth option is none of the above. So take your time. There is no hurry, but at least try to give the answer.
M3, M4, madam.
Okay. Anyone else?
M3 and M4.
Okay. I think there are two more students. Bhavani, what is the right answer?
M3 and N4, ma'am.
Okay. Gagan,
Yes, ma'am.
what is the right answer?
Ma'am, I just joined the class.
Uh, okay, take your time. See the circuit carefully and then find out the answer. Just you have to
Yes,
find
ma'am.
out the current source load transistor from the given topology.
Okay, ma'am.
So what is the right answer, Gagan?
Ma'am, I'm sorry.
Sorry, you are not audible.
Ma'am, I'm still solving the question.
Okay, take your time. Identify the current source load transistor from the given topology. Which two transistor is acts as a load transistor here? Can anyone explain little bit? Okay, no, no
Here
issue.
actually, M5 and M6 two MOS transistors actually act as a current mirror circuit for getting the bias current actually for the differential amplifier thing. And M1, M2 are the input circuits. That is the input transistor actually, where we give the input at differential input. And for this case, we taking the output as a single unit output, so it's an unbalanced type of output. So from looking from the drain side of the M2, we can see the M3 and M4 are the load registers, means the active load kind of things, where M3 is directly connected to the gate and drain. So it's a simply act as a resistors, and as the gate of the both M3 and M4 are shorted each other, so M4 also because M3 and M4 VGS is kind of same. So whatever the current is flowing, these two branch will be the same only. So that's why MC input has act as an active load, and we find the single-ended output gain at the differential mode.
Yes, good. So all of you got the answer, Gagan?
Yes, ma'am. I understood it.
Okay. So this is the question 2. If the following differential amplifier configuration correct, is the following differential amplifier configuration correct for determining the input common mode range? So see the circuit carefully and give the answer. So option A is no or option B is yes. And please try to find out the reason behind it. If it is no, then why? And if it is yes, then why?
I think it is correct for finding the input common mode range voltage.
Can you explain little bit?
I am thinking like for finding the ICMR, we have to find the two set of limits like VCM maximum and VCM minimum, for which we can apply common mode set both the input for uh, properly operating the amplifier in a common mode range. So for finding the VC max, it is like VT plus VD, where VD is VDD minus I by 2 into RD. So you can find that thing because ID is known, very much known, because whatever the current is flowing to the common current mirror circuit, from that thing we can find the I, and RD is also given. M3 acts as a resistor, so that is the equivalent resistor. You can find the RD. So VC max can be found, and for VC mean it is like V overdrive plus VT minus VSS plus V of current source. That is the voltage across the current source. But here we cannot get directly current source. But for finding the VCS, we can take the voltage drain to source voltage of the M of 6. That is, we can be act as a overall current source voltages. So from that thing, I am thinking the VC mean can also be found.
Okay. Pradeep, what is the right answer? At least try. Yeah. Hello. Bhavani, what is the right answer? Am I audible, Pradeep? At least try.
Yes, yes, you are audible.
Okay. I'm not expecting that all of you are going to give the right answer, but at least try. You can take your time. Okay, wait for 1 2 minutes. Then we will go for the next question. Bhavani and Pradeep. Pradeep.
Also, I think for finding the VC mean, common mode range, for the minimum common mode range voltage, we have there in the expression we have to find the VCS, that is the voltage across current source. But here it is like common current mirror circuit is there. So I think directly no passive current source is there. So I think for that reason maybe it is no, because we cannot find
No,
directly current
actually,
source.
first you have give the right answer. Actually, I'm just waiting to the other student also give the response.
Okay,
It
but
is you are right
what is that?
because
Is the reason?
you can determining the input common mode range from the
Hmm.
when they are saying about the common mode range, right? In that time, from the figure, how can just in short time, how can you find out? You can see the same common voltage is given to that M1 and M2 transistor, no? So from
Yes,
there
yes.
also you can find out that yes, this figure is right, and this is also determining going to use to determining the input common mode range. So this is a shortcut. Just see here the same voltage is applying to the both. Okay.
Yeah, but I'm thinking like for finding the VC max and VC min, the range, the input common mode range, like VC max so can be found. So it is VT plus VD, and VD is ID I into RD, VDD minus I into RD.
Next we are going to solve the question how to find this VC max and VC min. Okay.
Yes,
So
yes, yes. It will be
in
better
that
then.
case, you will get your proper answer. But here, this is
Okay, okay.
just a 1 marks MCQ question. So,
Like
at,
for because the connection is common mode connection, that's why you
yes,
were saying you can
yes,
find, na?
yes, yes.
Okay, okay.
Okay. Pradeep and Bhavani, at least try now. Please unmute yourself. Are you getting the point of what I'm
Yeah,
going to
ma'am.
explain?
Yeah, I'm little busy, so yeah, I'm continuing now.
Okay, okay. Pradeep, okay. So, the next question. So the second stage in a two-stage op-amp is normally a dash. First option is common source stage. The second option is the common drain stage. The third option is the common gate stage, and the fourth option is the none of the above.
So it is common source stage.
Okay. Another student. Pradeep and Bhavani.
Yeah, common source common source stage.
Okay. Yes, the right answer is common source stage. So the dominant pole in a two-stage op-amp normally comes from the first option is ground to input, the second option is input to the second stage, the third option is input to the ground, and the fourth option is none of the above.
It is input to ground.
Can you explain?
For dominant pole for two-stage op amp, we have to find like FH, the higher cutoff frequency, and FL, or lower cutoff frequency, for where the op amp is actually working in the midband region. So for finding the FH, we have to find the like if it is some capacitance will be there, like gate to drain and gate to source. So for finding the FH, main role comes into the picture, that is the input side you have to take in, and total input capacity you have to find like CGS plus CGD into 1 plus AV, that is the by using the Miller concept. So we have to find the input capacitance or input resistance, and the 1 by 2 pi RC is the equivalent resistance for finding the FH, and that will act as a like dominant pole for finding the frequency.
Okay, Shivajit, you can recheck the answer. Okay, just write down the question and please recheck the answer. It is input to
Okay,
second stage or input to ground. Okay, recheck the answer.
okay.
And this is question 5. When the load capacitor in Miller compensated two-stage op-amp is dash, the slew rate is decreased. The first option is increased. The second option is increase. Sorry, the first option is increase. The second option is unchanged, and the third option is decreased, and the fourth option is none of the above.
For decreasing the slew rate, we have
Slew rate,
to make the load capacitor is like increased.
yes. I think there are two more students, na? Why not you are responding? At least try.
I think only one student is there.
So Pradeep is left. Okay.
Yeah, Pradeep is here.
Last week he sent me a mail regarding to solve some question. So I already put some question according to their demand. So and he is also not here. Okay. So this is the question number 6. Identify the tail transistor from the given circuit topology. So see the circuit carefully and try to give the answer. So first option is M1 and M2. The second option is M3 and M4. The third option is M6. The fourth option is none of the above.
Yeah, it is the third option, M6 only.
Okay. And Bhavani, what is the right answer? Okay. All of them they left. Okay. So this session will end very soon because only one student, so it will not takes that much time.
Yeah.
So this is the question number 7. When the feedback factor for an op-amp with feedback is dash, the phase margin is increased. So the first option is reduced, the second option is increased, the third option is hold, and the fourth option is none of the above. And there is no worry, you take your time because I have to complete at least 1.5 hour, because for one student I can complete it within 30 to 40 minutes. I don't know what is the issue they are living. Um,
I cannot recall it right now. Uh, what are you thinking? By introducing the negative feedback, the gain is
when the
reduced.
feedback factor for an op-amp with feedback is dash, reduce, increased or hold, then the phase margin is increased. When the phase margin is increased?
Phase margin is increased, like
When the
phase margin
feedback
is
is
180 degrees.
reduced or increased or none of the above. Take your time. There is so much time now. But
Yeah,
think.
it is.
And it is very difficult to teach only one student. because I have to cover total 2 hours.
I think it is increased.
Yes. So sorry. No, this is not increased. This is reduced. You can recheck the answer. Okay. If you have any doubt, the answer is reduced.
Okay.
This is the question 8. A Miller compensated two-stage op-amp has dash at a frequency. Right half plane 0, left half plane 0, or left full plane 0. Or option D is none of the above.
It is left plane pole 0.
Think. Right half plane 0 or left half plane 0.
Yeah, 0 is in it is in left hand side.
Well,
1 plus GM times SC.
uh, according to me, it is right half plane 0, but you can recheck the answer, okay? Recheck
1
it.
plus S times is coming.
This is the question 9. The gain bandwidth product of a Miller compensated two-stage op-amp is given by the ratio of the first option is transconductance of the input transistor and the compensation capacitor. The second option is transresistance of the input transistor and the compensation capacitor. The third option is transresistance of the output transistor and the compensation, and the fourth option is none of the above.
Option A, transconductance by capacitor.
Yes. So this is the question 10. Find out the S domain, and this question is especially for Pradeep, I think. Find out the S domain transfer function H is equal to V 0 by V input for the circuit.
It is coming 1 plus SC by 3 plus SC, where C is that capacitor, 0.4 microfarad.
Okay. Let me solve the question. If you are taking this is so equivalent resistance or equivalent RT. This is RT. So tell me what is the value of RT? 100 kilo ohm is parallel with this capacitor. And how to write this one? So,
1 upon SC.
okay.
একটু আছে হবে গরম হয়ে গেছে
Yes. Okay, we can write directly here the R. At first, we can calculate like this. The RT equal to R parallel with 1 by CS.
Yeah.
CS
R1 parallel with 1 by S2.
1 by CS. Then what is the value of RT? R1 into 1 by CS. Then R
R1 by 1 plus S2.
1 by CS. 1 plus R
SC R1.
CS by R. Right?
Yeah, yeah.
Then what is the method? Find out the output by the input. This RT plus that one.
Yeah. So by solving this only, it is coming 1 plus SC by C plus SC.
Okay, let's solve and then see. Because I have to cover it now. The 2 hour I have to cover it. Only
Huh.
I'm going to give the give the answer only. Then it will only take the hardly 30 minutes.
Yeah, I also go like 7:45. I have also some
Yes,
another
yes.
meeting.
When you have finished your time now, you can leave. I have no issue. But I have to continue it up to 2 hours because
Okay.
I have to upload all the session also.
In the YouTube. Yeah,
You can understand it.
yeah.
Just write down the value into 100 in kilo ohm. 50 into 1 plus is into 0.4 into 10 to the power minus 6. Kilo ohm. So today's Ganesh Chaturthi also, so most of them are going to celebrate it. So from there we are getting 1 plus is into 0.04 and 3 plus is into 0.04. Are you getting
Yeah.
this answer?
Yes, yes. 1 plus SC by 3 plus SC.
So this is the question 11. Find out the transfer function of the V0 by V input of the RC circuit. From this figure, express it using W naught, which is equal to 1 by RC.
Okay. It is coming J of omega upon omega naught by 1 plus J of omega by omega naught.
So the value of R omega H omega equal to V out by V input, which is equal to R by R plus 1 by J omega C, which is equal to
कार्ड है
J
जाएगा
omega C into R
हम्म?
plus 1 plus J omega C into R. So h of omega we can write down j omega by omega 0, because here omega 0 omega naught equal to 1 by RC, and 1 plus j omega by omega naught. So this is the value. If you want to j omega, then this value is omega 1 omega naught by 1 plus omega by omega naught square. Okay.
Ready?
So this is the question 12. Obtain the transfer function P naught A by V input S of the circuit in the figure. So find out the answer. So please try to find out the answer. So here in this circuit, So in this circuit, just find out the V output. A plus A by S. How this 1 by 8 by S is coming? We know that for the capacitor 1 by 8. So how we will write down is for the capacitor 1 by Cs. So here 1 by C, it means 1 by 8 into S. So we can write it by 8 by S. Okay. And V input by total. So 10 plus 2 plus 8 by S. So the value is coming out 2S plus 8. And here 12S plus 8. So you can cancel out S plus 4 by so the right answer is S plus 4 by 6S plus 4. Okay. So this is the question number 13. For the circuit shown in the figure, find HS which is equal to V out by V input in S domain. So how to find out this type of question? So first, so we have to find out this. Just here, we are taking the V1. To first convert this 0.2 farad in S domain 1 by CS 0.2 into S. What is the value of it? 5 by S. And then this 1 farad. So 0.1 farad, which is equal to 1 by CS or C, which is equal to 10 by S. Okay. Then find out the Z. So here from this side, this circuit, we can take the equivalent impedance Z. So what is the value of in that case, what is the value of Z? This is 10S and this is the 5 by S and this is the 10 by S. So Z equal to actually from Z0, yes, from this side we are taking this 10 by S is parallel with the 5 plus 5 by S. So this one and this one is in series, which is parallel with this 0.1. Then what is the value of it? 10 by S into 5 plus 5 by S by S plus 5 plus 5 by S. Now just calculate this. We can find out this equal to 5 into this is second bracket, okay, S plus 1 by S, and this is 5 by S. I'm just taking common. Three plus one is okay. So from here we are getting 10 by s into s plus 1 by s plus 3. This is the right answer. Sorry. And then this is the z, which is that portion. So now we have to do that. This is the next part. V1 is equal to this voltage V1, which is equal to this. We can use the voltage divider rule. V input by Z plus 2. This is Z. This is 2. And this is number 1 equations. And then V output. Then V output equal to, from that side we are calculating. So V on into 5 by 5 plus 5 by S. 5 by S. So it is the value S by S plus 1 into V1. Now I'm going to erase this portion. So next what I have to do, we are getting from this equation this V output equal to S by S plus 1, then V1. Just put down the value of V1 here, S by S plus 1 into Z by Z plus 2 into V input. Now we have to calculate the Hs. What is the value of Hs? V output by V input. So S into S plus 1 by Z by Z plus 2. So now write down the value S by S plus 1, 10 by S into S plus 1 by S plus 3 by 2 plus 10 by S into S plus 1 and S plus 3. Then what is the value of it? 10S into twice of S into s plus 3 plus 10 into s plus 1. Then the value is 5s s square plus 8s plus 5. So this is the answer. So the next question 14 is find out the transfer function h omega equal to V output by V input of the circuit shown in the figure. So in the first figure, how we will find out the h omega, which is V output by V input. So here the R is parallel with this capacitor. So what is the equivalent impedance here? From this side, which is R equivalent R parallel with the capacitor. Okay, so how we will write the capacitor here for S domain when we are just taking this omega j omega c, and what is the value of it? R in parallel R into 1 by j omega c, then R plus 1 by j omega c. Okay, so if you write down the value, then it will be 1 plus j omega rc. Then how will write down the h omega? Yeah, by the input. R by 1 plus j omega rc by v sorry by j omega l, because there is impedance. Okay, plus this is l r by 1 plus j omega rc. Okay, then what is the value? R by r plus j omega l into 1 plus j omega rc. And this is the value of it. So for the first case, the answer is that one. Okay. Now we are going to solve the second case. So so how to find out h omega equal to r plus j omega l, because there is a inductance is there. Then r plus j omega l plus 1 by j omega c. J omega c r plus j omega l by 1 plus j omega c into r plus j omega l. Okay, then what is the value for the second case? J H omega equal to minus omega square LC by J omega RC. One minus this, that one, the minus omega square into LC plus J omega RC. Okay, for the second case, this is the answer. Okay, I'm coming back in 1 minute. solve the question. So here for the circuit shown in the figure, find out the Hs which is equal to I0 S by Is S. So in this term we have to find out the Hs value. Okay. So for one H, how can we write down this one Q omega L or Sn? Okay. And here the L value is 1, so this value is S. Now we have to find out the equivalent resistance, sorry, equivalent impedance. So right, Z equal to this two things, this side, okay, and this side. It's one resistance and that one. So this parallel with this one resistance, okay. So this one is plus 1. Now convert the current source to a voltage source. So what will happen in that case? The current source is converted into a voltage source. The circuit becomes okay, minus plus, and this will be Is into one resistance. Okay, and then the resistance 1 ohm will come. Then there is a impedance inductance 1H, and there is a Z, that one. Now, how to find out this V output? The output is Z1 Z plus 1 plus S into V input. That means Is into 1. So Is, then just put down the value. Is by is plus 1 is plus 1 is 1 is plus 1 into Is. Okay. What is the value? S into Is by is square plus 3S plus 1. Okay. This is the value of V output. Now, here. Then, what is the value of I0? I0 is flowing through this 1 ohm. So, I0 is V output by 1 ohm. So, I0 equal to is into now, just put the value of V0, Is, then this is square plus 3S plus 1. So now we have to find out the value of I0 is by Is. So from here the I0 by Is equal to S by S square plus 3S plus 1. So this is the right answer. So Pradeep, I think this is your question number 16. So find out the constant for the following circuit. Can you please unmute yourself?
Yes, madam. Yes, madam. Yes, madam.
So
Yes,
now tell me
madam.
how to find out the
Yeah,
time
the,
constant.
the time taken to reach the 60 percentage of the final value, we are calculating 0.693 something. RC is the time constant, madam.
Yes, how to find out the equation I am asking about. This is the RC. Okay, so here this
Okay.
R and C, all those things are given. So I think this is not that much difficult now. Find out. So if the R value is
Correct,
given
correct, madam.
and the C value is given, just put down that value here and you can directly find out the tau, the time. Okay.
Yes, madam.
So this is
Yes,
the
madam.
next condition where R1 and C1 is in series and this there is a R2 and V out. So in that case, when the V input is given and also the output is taken from the R2 side. Now tell me how to find out this. Just this this circuit, na, you just have to convert it the RC circuit, just simple
Okay.
RC circuit. And whatever the voltage source is given, you have to, if the voltage source is given, just you have to short it. Okay, and if the current
Okay.
source is given, you just have to open circuit it. Now tell me how
Okay.
this circuit look like. This will short now, and there is a R1 resistance and there is a capacitance and also there is a R2 resistance. Now just convert it like a simple RC circuit. Now tell me what is the R value or R equivalent value for this circuit, because there is a C we
R1
can.
plus.
Yes, yes,
Yes, madam.
yes. R1 plus R2, right? This is in
Yes, madam.
series. R1 plus
Okay.
R2 and this is in C1. So now tell me what is the value of time constant.
R1 plus R2 multiplied by
R1
C1,
plus
madam.
R2 multiply with C1. This is the time
Okay.
constant. Okay, and this is the third case. So now
Okay.
tell me in this circuit how we will convert it. V1 is short,
Ah,
okay.
okay.
Then R1 which is parallel with this R2,
Okay.
then it is parallel with the C. Just simply convert it into the simple RC circuit. Now tell me what is the value of
Okay.
R and what is the value of C. Just
R1 parallel R2 multiplied by C2, madam.
yes. So this value
Yeah,
is
voltage
R1.
circuit, short circuit, and current circuit
Yes,
open. Current source should
yes.
be open. Okay,
Yes.
thank you,
Then
madam.
just convert it into this simple RC circuit or R equivalent C equivalent circuit. Okay. So R1 into R2 by R1 plus R2. Okay.
Okay,
So this time constant will be R1 into R2 by R1 plus R2 and which is
multiplied by C.
C2.
Multiplied by C.
Yes. So this is the right answer. So now tell me in this condition you find out the value of tau and then tell me.
Yeah, R1 parallel R2 multiplied by C1 plus C2. C1 C2 are parallel means C1 plus C2. So
Yes.
R1 R2 by R1 plus R2 multiplied by C1 plus C2, madam.
So this is short and there is a capacitor which is parallel with the resistance C1 R1 and here also like R1 R2 and there is a C2. Okay, and this is short. So how we will find out? So this R1 and R2 parallel condition and also this is in parallel condition. So if we convert it in simple RC circuit, so it will look like R1 parallel with R2 and the C1 parallel with C2. So how C1 parallel with C2. So what is the value of time constant? R1 into
R1
R2.
R2 by R1 plus R2 multiplied by C1 plus C2, madam.
Yes. So if uh, capacitor is in parallel, then C1 plus C2. So this is the answer. So this is the another condition So now tell me how we will find out the T value. Just simply convert
R1,
it RC
yes,
circuit.
madam. R1 plus R2 multiplied by C1, C2 by C1 plus C2. Maybe wrong.
Mm.
Okay.
At first see the circuit. It is short now, so there is a voltage
Yes.
source.
Yes.
Then
Yes.
R1, then there is a capacitor C1,
C1.
and there is a
Okay.
resistance R2, and there is a capacitor C2.
Yes.
Okay. Now tell me if we convert it normal RC circuit, how it look like? What is the value of R equivalent here? R1 plus, because it is in series now. This total is in
Series.
series. R1 plus R2, and what is the value of C? If capacitor is in series, then what is the value of C equivalent? Hello. Am I audible, or I lost my connection? Hello. Hello.
Yes, madam. Yes, madam. Suddenly
So what is the
disconnected. I
value
don't
of
know.
C equivalent? Okay, okay, no issue.
C
What is the
C1
value of
C2
C2?
by C1 plus C1 C2
Yes,
by C1 plus C2.
C1 plus C2. So I think the other one or two, I think I skipped. So
X
you can find out.
XC1 XC1. Yes, yes. Yes.
You can find out that like that way. Just voltage source you have to do this is short, and then just find out the equivalent R or equivalent C, and just convert it
Thank you, ma'am.
simple
Thank
RC circuit. So the RC is R1 plus R2, and C is C1 C2 by C1 plus C2.
Thank you. Thank you.
Okay, so this is the right answer. So calculate the time constant for the RC circuit shown here. So please try to find out, and it will more clear your doubts, I think.
120 parallel 80 plus 12 ohms multiplied by 200 microfarads.
Okay, then what is the total value?
Yeah.
Take your time. There is no hurry, because
Yes, yes.
at today class only two three students couldn't have joined. All of them are dead. Are you trying?
9.6 millisecond, madam.
Okay, let's solve the question. Just
120, 120 multiplied by 80 ohms. 120 parallel with 80 ohms. plus 12 ohms multiplied by 200 microfarad.
Okay, let's calculate it. So I have already told when we have to
Yes.
find out the RC circuit, just short this voltage source 120 ohm, which is parallel with this 80 ohm, and then there is a 12 ohm and this capacitor, which is 200 microfarad. So this 120 and 80 is parallel.
Parallel.
So our equivalent is 120 parallel with 80 plus 12, right? 120 into 80 by 120 plus 80 plus 12. So this is I think 200 and
Yes,
this
madam.
is
Ninth, 12
12.
eights, 9.
Okay,
Okay.
okay, okay. Cancel out this 20 and plus 12. Then
660 multiplied by 200.
yes. So I think you have done some calculation mistake, right?
Yes, madam. 12 I
This
missed. 12 I missed. 12 I
yes,
missed.
yes. This 12, no?
Yeah,
Yes.
yes, madam. I missed. I missed.
Oh, okay. Then just we have to find out the tau value, which is the
Yes,
RC.
madam. I am not in home, madam. I am at outside, but I want to listen.
Okay, okay, okay,
Okay,
no,
that's why.
no issue. But at least you have tried. It's
Thank
okay.
you.
Okay. 200. Okay, today's Ganesh
10 power
Chaturthi,
minus 6. Yes, madam.
so all of them are busy. All of the students also are celebrating in our college also. They're
Yes, madam. Yes,
celebrating the,
Navaratri, Ganesh
the
Navaratri,
yes,
madam.
yes. But here I have to take the class. There is
Yes,
no
madam. I
option.
understand. I understand.
So this is the right answer.
Yes, madam. Yes, madam. But nicely, I understood the concept of. I understand the concept of time constant, madam. Thank you, madam.
Okay, okay. So we have to find out the time constant of the given circuit. So there's a circuit is given, so you
R
can
by
take
2, R by 2 plus R by 2 parallel with R multiplied by 4C by 3. Okay.
hmm. So let's start. We have to find out the R equivalent.
3R by 2, 3R, oh, okay, madam. 12 RC, madam. Answer is 12 RC.
Okay, let's see.
Okay, madam.
Okay. So R and R, this is parallel.
R by
So
2.
R plus R by 2, this is the equivalent resistance. So resistance value is 3R by 2 and the T is equal to C equivalent into R equivalent. C value is 4C by 3 and R equivalent is 3R by 2. Okay, just 3 cancel out and 2. So value is 2RC. So please check it.
Yeah, yes, madam.
This
Correct,
is
madam.
3R by 2 and then that one the 4C by 2. So
Yes,
it
madam.
is coming out 2RC. This is the answer.
Okay, okay.
So this is the last question. Actually, there are today class only one or two students, and that's why it is
Yeah, yeah,
you know
fine, madam. Fine, madam. Fine,
taking
madam. No
less
issue.
time. So this is the
Okay.
question 23 for the given MOS differential pair, and this is the last question. The
Okay, madam.
common mode input VCM is applied. Both MOSFET are identical, and following are the device parameters for both MOSFETs. VTH is given 0.5 voltage, and mu1 CoxWin is equal to 4 milliamps per volt square. And here lambda is also given, which is 0. So if the minimum required voltage across the current source is zero point 0.4, then find out the maximum and minimum allowed value of VCMR. So here the VCM is given, so we have to find out the max VCM and the minimum VCM value. And the this is the max. Okay, and the minimum VCM value we have to find out. So in which condition when the current so here the 0.4 voltage is applied when. So now just take your time and then try, at least try to solve, then I will solve it. So for the given differential pair, the common mode input VCM is applied. Both MOSFET are identical and the following are the device parameter for both MOSFET. VTH is given 0.5 and mu and CUX by L is given. So if the minimum required voltage across the current source is 0.4 volt, then the maximum and minimum allowed value of VCM are. And there is a one clue that the both transistor is in a saturation region. So how to find out this?
Madam, we should find ID na? ID na? ID.
Yes, we
Yes,
have to
ma'am.
find out ID, and
Yes,
at
ma'am.
first see the 0.4 milliamps current is flowing from here, and these two
Yes.
are identical. So
Okay.
from here how much current will flow, and from here how much current will flow, because this current is coming here and this current is here and both are full flowing this. So how
Yes.
much current will flow from this side?
Mu n
Like
Cx WL VGS minus
so
VT
tell me
whole
the
square.
value. At first tell me the, this is ID1 and this is ID2.
Point 0.2
So
milliampere, ma'am. Point
yes,
0.2 milliampere.
because ID1 equal to ID2, which is equal to ISS by 2. The value
Yes,
is
ma'am.
zero point 0.2 milliamps. Okay.
Yes.
Now we know that this both transistor is in saturation. So ID value we know that how to calculate half of mu1
Cx
COX
WL VGS minus VT whole square.
VGS minus VTH whole square. Then tell me how to calculate this VGS value. From this equation, what is the value of VGS?
2 ID by mu n Cx W by L plus VT root
And
over root over.
twice of ID, because from
ID.
that side we are calculating. Twice of ID is equal to this ISS, right? Here
Yes,
the
ma'am.
ISS
Yes,
is
ma'am.
flowing. So twice of ISS is I. So this is the ISS by mu n COX W by L. Okay, and this is root over,
Root
because
over
here the
plus VT
square
plus VT.
plus VTH. Okay. Now tell me from these two cases, now this VGS1 and VGS2 are both same, both are same.
Same.
So
Same.
VGS1 equal to VGS2. And how to find out this value?
Root
So
root over
ISS is given, yes,
point
ISS
0.4
value 0.4 milliamps, okay.
by
And the mu and COXW by L value is also given, which is the 4.
4 milliampere per volt square. Correct.
Yes. So the milliamps up and down side, and this VTH value is also given. So
Correct.
from
Correct.
this side, this is 0, which is
Point
coming
root
out
over
zero
point 1.
point 0.1, and this is coming out 0 0.5. Then what is
Okay.
the value? 0.816 volt or
Yes. Yes.
0.82 we can take 82.
Correct. Correct.
Then now we are going to solve the maximum.
Max. Okay.
VCM max, how to calculate the VCM max? So VCM max, for this case, when we are going to find out, now we know that this two transistor is in saturation, the VD is greater than or equal to VGS minus VTH. Can we write it?
Correct. Correct. Correct.
And this, sorry, this is VG. VD we are taking, so VG minus VTH. And this VG
Yes.
is that one, the VCM value, the gate side which voltage is applying. This is VGS. So VG is equal to VCM. Okay. So now calculate the value of VD. So VD is here. Okay, the VD, and here also VD. So what is the value of VD in that case? Tell me how from this circuit how you will find out the value of VD.
Yes, ma'am. Yes, ma'am. Yes,
The
ma'am.
VD value is VDD minus ISS by 2 into RD. It means how the voltage is here is the VDD value and the voltage drop according to this 5 kilo ohm resistance. Okay.
Yes, ma'am. Yes, ma'am.
So VD equal to, so VD1 equal to VD2 from both are identical, equal to 1.5 minus 0.2 milliamps into 5 kilo ohm. Okay, so the value is 0.5. Yes, 0.5 volt. So VD value we have gained. Then just write down the equation. VD is greater than equal to VG minus VTH. So, and we know that the VG is the gate voltage, so which is the VCM. So we can write out the VCM less than or equal to VD plus VTH. Okay, so VCM is less than, what is the value of VD? 0.5. Then what is the value of VTH? 0.5. Then the VCM is less than equal to 1. So maximum value it can goes up to on. Okay. So VCM max value equal to 1 volt. 1 volt. So first answer is that one. Okay. Now we are going to calculate the VCM minimum. So next, now we know that the VGS1 or VGS2 value is first we from here I think we have calculated 0.82. Previously we have calculated that. Now what is the minimum value of the VCM? VGS plus, and here what is the voltage is applied here? 0.4. This is the condition that the current source is 0.4 voltage. Okay, then the maximum and minimum. So this is the, here 0.4 voltage is applied, so VGS plus 0.4. Okay, and here the value is applied is minus 1.5. So here minus 1.5. Okay, so what is the value of VGS? Previously we have calculated the value of VGS is 0.82, then 0.4, then minus 1.5. Okay, so the value is minus 0.28 volt. So this is a VCM minimum value. So today up to this. Next session is next Tuesday, 7 to 9 p.m. Okay. Okay,
Okay, ma'am. Thank you, ma'am. Thank you.
okay, you can do.